Do you want to experience a live JVM crash? Do you want to know how VisualVM can be used for Java application monitoring? Then let's begin. So this is the interesting Java program which we are going to discuss today. So we have an instance variable which we are gonna initialize through this particular constructor, and we are creating a lot of objects here in the loop where I have used math function so that we can create a lot of objects so that we can see JVM heap is growing. So now we have a delay here, time delay, so that we can see how the objects are growing, and I'm displaying the list size. So this program will kind of exponentially create a number of objects. The same we can monitor using Visual VM graphs. Let's go to your JDK installation bin path. So once you come here in the bin path, you can see here jvisualvm.txt icon. So if you double click on that, you can see jvisualvm UI. So whenever you run any Java application, it will automatically appear here. You don't need to do any configuration here. So even Visual VM is a Java application, that's why you can see this icon. If you double click on this, you can see all the JVM parameters. So now let's run our application, break my JVM. So after every 5 seconds it will create a lot of objects, and in it will display the list in the console. So now let's go to the JVisual VM. So you can see the application got registered with process ID, this one, and if you double click on this, a monitoring UI will appear. So you can see all the basic JVM parameters are there here, and if you click on monitor, you can see a lot of parameters here. For example, CPU usage, you can see here the GC activity and the heap size and heap used and classes and then threads. So for example, now here there are 9 daemon threads and 10 live threads. So now if you go to threads, you can see the main thread which we ran here. So a lot of other threads are here. So now let's go back to monitor again, and let's take a heap dump. So heap dump basically means the all the objects which currently resides in your heap. So if you click on this icon, a heap dump will be created here with all these basic parameters like the size of the uh, heap dump and total classes, total instance. So basically how much objects are there, that's what it means. So if you go to classes, you can see the object of break my JVM which we created. So there are around 32,767 objects. So if you double click here, you can see all the instances here. So you can see here total the instance size of a particular object and total size of the objects. All these parameters you can see here. So for example, if you click on this particular object, you can see the inside 4141 is the value of this particular object. So basically we have break my JVM object with the string value, right? Now let's see what is OQL is. So OQL is basically object query language. So this meant for basically to query Java heap memory. I'll show you an example to query the heap. So I have a query which basically says let's get the break my JVM object which is having inside 11 as the value. So you can see the object got appear. So if you double click on this, you can see that value. So this is the object, and you can see that inside 11 value. So now if you want to check something else, for example, say rather than saying equals, I'll say contains. and I'll say 11. So here you will get all the objects which are having the value 11. So for example, so you can see all the objects. For example, I'll open, for example, this object. So you can see it contains 11 here. So that's how we can utilize OQL to retrieve the objects. Now let's go back to the monitor, and we can see the application is utilizing more than 4 GB of memory, and it's keep on creating objects. So as there are a lot of objects are getting created, it's keep on waiting there. So let's go and stop this application for now, and let's have a limit. And so as there is no limit right now, the application is keep on growing. Let's have a limit, upper limit for the JVM heap, and then we can run again. Let's make this change where we will decrease the delay to 1 second, and let's run the program. So right now when I running this program, I'll have a maximum heat memory to 500 MB, and then I'll run this application. So now if you go to the VisualVM, if you double click on that application, you can see the application is growing quickly. And it will go till 500 MB. It will not grow above this. So that's how the limit helps. So you can see here GC activity. It is trying to reclaim the objects. So now if you go and see the objects are growing here. Now you see the application stopped working and JVM crashed. The JVM failed with out of memory error as garbage collector could not reclaim memory. That's how you can monitor locally running Java application, but you can also monitor remote running application by having a remote connection from Visual VM. But you need to enable JMX port here. There are other ways also where you can get heap dump. So first method will be to run jcmd command where you can get the heap dump, and second way will be to enable the heap dump on out of memory error flag in the JVM while running the application. So this will create the heap dump in the location where you are running the application whenever the JVM throws out of memory error. So if you want to give different path, you can use heap dump path. So once you get the heap dump, you can load that in the Visual VM using this option. You can refer Oracle's Visual VM documentation, which has all the information on this. Please find the link in the description. You are here means you have learned something new today. Please add your queries and feedbacks in the comment section. Thank you.